Okay, now we're going to try to build some robots using the builder pattern, the builder design pattern, and the robot builder class. I'm going to call this program, this testing program, the test robot builder. Now, first of all, we want to determine whether or not the person who's using the program wants a cookie robot or an automotive robot. We saw the cookie robot, how that's cookie robot buildable class was constructed in the previous movie. Also, we have now a automotive built robot builder class. So we're going to give the user a choice whether or not they want the cookie robot or an automotive robot. So they type C if they want a cookie robot and A if they want an automotive robot. Okay, and then we read their response, and depending on what they typed, the response equals C. We're going to create a new cookie robot builder object just called builder. We'll store it in the builder object, the builder variable up there, and if the user typed C, we're going to create a cookie robot builder. Otherwise, we're going to create an automotive robot builder. So those are our robot builders, and now the client code has the option of configuring the robot that will be created from those builders. And here's how that works. I'm going to say builder.addStart. As you recall, the builders support addStart, addTest, addAssembles, addGetParts, and so forth methods. We're going to configure the sequence of actions that our robots undertake by saying builder.addStart, addTest, addAssemble, addStop, and this is going to configure the robot under construction to have a start method, to call the start method, then the test method, then the assemble method, then the stop method in that order. So that's how you can work with a robot builder. And then after the robot has been constructed, we're going to use the builder's getRobot method. The getRobot method gets a robot object. That robot object will be stored in a robot buildable variable called robot. So then we're just going to use the robot's go method to confirm that the built robot is in fact been built to our specifications. So that's how it works. That's how the test works. We're going to check and see whether or not the user wants a cookie robot or an automotive robot. Then we're going to create a cookie robot builder or a automotive robot builder. I'm going to use that builder. This is part of the builder design pattern. We're going to use that builder to configure the robot we're creating, and you do that with the addStart, addTest, addAssemble, and so forth, different methods. You can use those methods as often as you want, at whatever sequence you want, and that configures the robot you're building. And then finally you say builder.getRobot. That actually gets the robot under construction, and then you have that robot object, and you can use its go method to check whether or not it's been constructed correctly. So let's take a look, and in this case we should see the sequence of actions: start, test, assemble, and stop. So let's take a look whether or not the test robot builder sample application has done what it's supposed to do. First of all, we're being asked if we want a cookie robot or an automotive one, and let's ask for a cookie robot. There you are. The cookie robot was created, and the actions have been performed here in the correct order, and the go method, so the go method of the robot actually worked, and that's in a nutshell how the builder design pattern works. It allows you to create builders that let you configure the objects that they build. Similarly, if you want to create an automotive robot, you could do that as well, and that would be configured differently, and that is, the actual implementations of the methods would be different, but the sequence would be the same: starting and testing and creating or assembling and stopping. Okay, let's take one last look at the builder design pattern in overall schematics and the client code. You start off with the client code. The client code can work with a builder of some kind and use these add methods to create the sequence of actions that the robot under construction or the object under construction by the builder is going to perform. And so that sequence can be, you can specify the number of actions and the order of their actions and so forth. You're able to completely configure the object being built by the builder. And then you call the get method, which gets the object that's been built. In this case, that's going to be getRobot. You get the robot object, and you're able to run the robot's go method and have the robot object perform whatever you want. And in addition to working with cookie robot builders, you can use other robot builders as well. Automotive robot builders, for example, will build cars, and it just depends on what kind of builder you're using. Gives you a different object back, a different robot object back in this case. So if you want to build a cookie robot, you use a cookie robot builder. And if you want to build an automotive robot, you work with an automotive robot builder there, and then configure it as you like, the actions it should undertake, and then use the get method to get the object under construction by the builder. And then you can work with that object using, in this case, its go method to confirm that it's been built correctly. So you see, it's a little more involved than some of the previous patterns we've seen, but it also allows you to customize the objects that are being built to good effect. So keep this one in mind. It's a useful tool, this pattern, and once again, it allows you to extract the code that changes most in your core code and allows you to extract that to a builder, which then returns objects, configured objects, that you can use inside your core code. So again, the idea here is to extract the code from your core code, the volatile code. Extract the volatile code from your core code, and that volatile code changes a lot. You don't want to have that inside your core code because editing that core code is not a good idea. Instead, you want to be able to edit code inside the builders and let you customize what goes on inside the builders. So that's the builder design pattern.